Hey guys, so let's discuss the concepts of displacement, average velocity, average speed, instantaneous velocity, and instantaneous speed. So displacement is of course a change in position, for which of course you need to define a coordinate system before. And average velocity is displacement divided by the time interval. Average speed, there's no standard variable for speed, so I'm just going to write speed average, and that's the total distance divided by the time interval. And instantaneous speed velocity is the limit delta t approaching 0. If you take the limit delta t approaching 0 here, you get instantaneous velocity. So that's just the derivative. If you're taking algebra-based physics, so these three are enough for you. But if you're taking calculus-based, then you need to know this. Okay. So, and then instantaneous speed is just the magnitude of average of instantaneous velocity. Okay. So just make sure you remember this. These are definitions that students confuse a lot. What is the difference between average velocity, average speed? So let's look at a few examples. Okay. So let's look at a few scenarios. Let's use a different new page. So let's say that, well, Thomas will help us today. Thomas the train, right? So let's say that Thomas at x equals 0, at t equals 0, Thomas is at x equals 0, and then at t equal, after 2 seconds, Thomas is at x equals 10 centimeters. Okay, so let's look at the displacement and average velocity and average speed of Thomas. So initially Thomas is at 0 centimeters. Finally, Thomas is at 10 centimeters. Okay, again, Thomas travels at just 10 centimeters in 2 seconds. Okay, and delta t is 2 seconds. So, so displacement of Thomas is x final minus x initial. That's just easy. It's just 10 centimeters. Okay. And average velocity, this is the simplest scenario that can be. So average velocity is delta x divided by delta t. So delta x is 10 centimeters. Delta t is 2 seconds. So you get 10 centimeters divided by 2 seconds. So that's just 5 centimeters per second. Okay. So that's the average velocity of Thomas. And in this case, since it's just motion in one direction, the average speed is going to be just total distance divided by time, which again is just 5 centimeters per second. Okay, so in this case they're the same. Let's look at another scenario. So like this is scenario 1, this is scenario 2. So in scenario 2, what Thomas will do is Thomas will start at x equals 0. X equals, let's say, 15 centimeters. Okay, and then Thomas will move in the backward direction. So Thomas will, in 2 seconds, Thomas is at 5 centimeters. Okay, so x initial is 15 centimeters and x final is 5 centimeters. Okay, so let's see what do we get. So it's easy again. X initial is 5 centimeters. Sorry, 15 centimeters, and x final is 5 centimeters, and delta t, let's say, is again 2 seconds. So, so delta x is 5 minus 10, x final minus x initial, so you get negative 10 centimeters. Notice the negative sign, and delta t is 2 seconds. So average velocity is negative 5 centimeters per second. So it's delta x divided by delta t. And average speed now average speed is going to be just the magnitude of this. Okay, it's just well, average speed is, well, let's just calculate. It's just total distance. Total distance is also 10 centimeters. So in this case, it's just easy. It's just 10 divided by 2. So speed is total distance divided by time. So it's 10 centimeters by 2 seconds. So you get 5 centimeters per second. So it's just you got rid of the sign in this case. In this case only, we'll look at another scenario where they definitely, you'll see they're different quantities. So the negative sign is important. Displacement is a vector quantity. Of course, in 1D, vectors are easier to handle because just one direction. So the positive sign for displacement tells you that Thomas is moving in the positive direction, and the negative sign for displacement and of velocity is that Thomas is moving in the negative direction. Okay, so they get opposite signs if the object is moving in the opposite direction. So negative direction means negative sign, positive direction means positive sign. Let's look at a third scenario. Okay, so in the third scenario, we have situation where Thomas starts again at x equals 0, okay, and goes to x equals 10, and then comes back to x equals 5 centimeters, okay, and he does that in 3 seconds. So again, starts at x equals 0, goes to x equals 10, and then reverses to x equals 5. Okay, so now the situation is going to be different. X initial is going to be 0 centimeters. X final now is 5 centimeters. Okay, and Thomas does that in 3 seconds. Okay, so then average velocity is going to be displacement divided by time. Now displacement is x final minus x initial, so 5 minus 0. So you get 5 centimeters divided by 3 seconds, which is around 1.67 centimeters per second. Okay, and average speed is now going to be different. Okay, it's obviously not the magnitude in this case, because average speed is total distance. Total distance traveled by Thomas is 10 and then 15. So you get 15 centimeters. So it's like total distance divided by time. So it's like 15 centimeters divided by 3 seconds. So that's 5 centimeters per second. Okay. So you can see that the answers are different now because total distance and displacements are different. So that's an example of average velocity and average speed. So average velocity, you can think about average velocity as giving you an overall result of what's going on. So overall, Thomas moved after 3 seconds. Thomas just moved 5 centimeters. So essentially, like he's moving 1.67 centimeters per second. So 1.67, and then around like 3.4, and then around, so after 3 seconds he's just at 5. So it's like the overall effect of the motion, right? But average speed is is actual, like taking into account of every step he takes, like 5 centimeters per second. He's actually moving 5 centimeters, right? So it takes into account the whole motion. So that's one way of thinking about average velocity and average speed. So we'll discuss our instantaneous velocity, instantaneous speed in a different video, because we'll take like an example of x as a function of time, and then we'll take the derivative. But for now, let's just stop over here and make sure that you understand these 3 simple examples. Thank you for watching. Hope you liked the video. Please subscribe.